Okay, so we've talked about several formulas on our formula sheet. On your last test were the sum and difference formulas. Sorry for that being in the middle of the screen. The sum and difference formula, so we dealt with those. Uh, Today in class, we dealt with these double angle formulas. And again, none of these you have to have committed to memory. We're going to use the formula sheet on all of those. If you take calculus, in particular Cal 2, these power reducing formulas come up. Sometimes it's easier to work with something that's something to the first power as opposed to something to the second power. And I'll tell you that those formulas really are nothing more than solving for a portion of something in the double angle formula. So that one is always built on the other. But today, what I want to talk about are the ones on the right hand side, and they're some of the easiest ones of all. The product to sum, changing from multiplication into addition or subtraction, or a sum to product, changing from addition and subtraction into multiplication. Okay, so again, these are not bad problems at all. They're actually relatively easy. And to look at some examples, let's look on page 220. Page 220. And I'd like to begin with number 56. Number 56 says 2 cosine of 85 degrees times the sine of 140 degrees. So I want to change that from a product, a multiplication problem, into an addition problem. So again, I'm interested in my product to sum formulas. And so I just need to match it up with one of these. So that problem is essentially a cosine times a sine. So it's going to be this last formula. And I'm going to let 85 degrees be my u, and I'm going to let 140 degrees be my v. So again, back to my problem. This is u, this is v. Notice there is no 2 in that formula. So the substitution that I'm making is simply for this part of that problem. Okay, so let's just plug that into our formula. So that 2 is still there. And then I want to use the formula. And again, I'm using the last formula on your formula sheet. So everywhere we have a u, we're going to put in 85. Everywhere we have a v, we're going to put in 140. So that becomes a 1/2 times the sine of 85 plus 140, and then minus the sine of 85 minus 140 degrees. All right, so the rest is just the arithmetic. So notice a couple of things. One is I have a 2 times 1/2. Those are going to actually just cancel each other out. And then I can do the arithmetic inside parentheses. So this becomes the sine of 225 minus the sine of, a negative 55 degrees, I believe. And y'all, for the most part, an answer like this is going to be sufficient. We have an identity out there for a negative angle. It's in your notes. Go back and look it up. I told you we would need those another day, and so today is that other day. So the sine of a negative angle is the same as the negative sine of the positive angle. Again, I am not factoring that negative sign out. This is just a true statement, okay? So if I make use of that identity, the sine of negative 55 is the same as the sine of positive 55. And so the best answer probably here is sine 225 plus the sine of 55. The book is going to do one other thing here. You're not going to need to do this, but they will. The sine of 225 actually is a special angle with a reference angle of 45 degrees, so I can actually find its value, which is a negative square root 2 over 2. I don't think that's even necessary to do that because I don't know anything about 55 degrees. So I'm going to leave my answer to be the answer there in the box. All right, that 1/2 way back up here can cause you some grief, and so I want to talk about that for just a second in light of number 58. Number 58 says the sine of 4x times the sine of 5x. So again, I still want to go from a product to a sum, and I'm multiplying sine times sine. So I'm going to make use of this first formula. And I'm just now noticing that when I sent this to be printed, I use a equation editor, and all those parentheses went away, so maybe stick them in. Sine times sine. So once again, I'm letting this part be u and this part be v, and let's fill it into that formula. So I have a big 1/2 times the cosine of the difference in the angles minus the cosine of the sum of the angles. And again, that's directly on my formula sheet. So let me deal with the stuff inside parentheses. So 4x minus 5x is negative x, and 4x plus 5x is a 9x. And I can do a couple of things here. The first one is I'm going to make use of that negative angle identity for cosine. That was the tricky one, or the one most students don't see. The cosine of a negative angle is the same value as the cosine of the positive. So I can actually make that into just cosine x. And I still have a 1/2 times all of that. Y'all, this is the place that students go wrong all the time. This is not 1/2 times x. It's 1/2 times the cosine of x. That's some value, and it's that value that I'm taking half of. So I can't ever distribute 1/2 over there in the angle. It's always just 1/2 times those cosine values for that answer. Okay, so that's all there is to the product to sum formulas. They work out relatively nice. And let's look at the last group, the sum to product. And to that end, let's look at number 60. I'll get my page lined up. There we go. Number 60, we have the cosine of 5x plus the cosine of 8x. And again, I want to change that from a sum into a product. So I look on that last group of formulas. It's cosine plus cosine, so I'm using this formula right here. And here I've used x's and y's before using v's. It doesn't matter. But I'm letting the first one be x and the second one be y, and then I'm just going to fill in the blanks as I go. So we're going to let this be x, and I know it's already got an x in, but it's it's just a placeholder. So that formula says 2 times the cosine. And the formula says to add them together and divide by 2. So 5x plus 8x divided by 2 times the cosine, and it says to subtract and divide by 2. So the rest of that is just arithmetic. One more time, y'all. I can't cancel 2's here. It's not 2 times this angle. It's 2 times the cosine of that angle, and it makes a difference. So in this first parentheses, I get a 13x over 2. In the second parentheses, I get a negative 3x over 2. And I'm actually almost to an answer. One more time, I'm going to use that negative angle identity and rewrite that as cosine of 3x, positive 3x over 2 for that solution. Now, these are some of the easiest formulas that exist. These are nothing to work with. Let's do one with a number in it, number 62. Number 62 says the sine of 102 degrees minus the sine of 95 degrees. So again, it's a sine minus sine situation. Sine minus sine. So I'm going to use the second formula in that group. And again, I'm treating this as x and this as y. So let's fill it into that formula. And so that says 2 times the cosine, and it tells me to add x and y together and divide by 2. And then multiply that by the sine, and it says to subtract those two things. Once more, we can't cancel 2's there. We aren't able to do that. But I can do the arithmetic. This becomes 197 over 2 and 7 over 2. So since those are both numbers, we can do the division if you want. For that matter, you can probably leave it like that. Half of 197 is going to be, I have no earthly idea, whatever it is, times the sine of 3.5 degrees. So you can do that computation if you want. Easy formulas. You don't need to memorize. You'll be able to use your formula sheet. And we'll talk about that homework next time. Thanks.